Welcome back, dear students, to the tetrahedron chemistry classes. So this is the question which was asked in the engineering chemistry B.Tech first year examination of Uttarakhand Technical University, right? And in which you have been given two complexes. First one is the hexacyanoferrate 2 ion, and it is already given in the question that the first one is the diamagnetic and the second one is the paramagnetic, and it was asked that why this is actually happening. So for this, first of all, we will calculate the oxidation state of the iron. So we'll put the X in place of the iron and the plus sign, and say -1 charge is present on the cyanide and 6 times cyanide is present here. So -1 into 6 equals to -4, because overall the complex is having negative charge. So if you solve this, then you will find the oxidation state of iron is +2, and for +2 iron is having the atomic number 26. When you remove 2 electron from it, it left with the 24 electrons. And if you write the electronic configuration of the 24 electrons, so this 18 for the argon, and then you left with the 6 electrons, and those 6 electrons will go into the 3d orbital. So it is 3d6, and you know it is an octahedral complex, and when you do the crystal field splitting in the octahedral complexes, so that 5 orbitals will split in this manner, where Eg will have the higher energy while T2g have the lower energy. Since this cyanide is a very strong ligand, so the crystal field splitting very high, right? And pairing energy would be low, and the complexes will prefer the low energy pathway, and all the 6 electrons will get paired in this particular T2g set of the orbitals. So all electrons are paired. That's why it is diamagnetic in nature, and its magnetic moment would be 0. And similarly, if you calculate the oxidation state of iron in this particular complex, it is again 2, right? And again the configuration will be the same, 3d6 configuration. But if you, when you draw the crystal field splitting for this one, you know the chlorine is a very weak ligand, so your splitting would be very low, and your pairing energy would be very high, right? Since the pairing energy would be very high and crystal field splitting is low, so it will prefer the low energy pathway. So electron will not get paired in the T2g set like the earlier one. But first of all, we'll put all the electrons, one each electron in all the available orbitals, right? So 1, 2, 3, 4, 5, and then the sixth one we left, we'll put the sixth one here. So this complex is having 4 unpaired electrons, 1, 2, 3, 4. So that's why it is paramagnetic in nature. And if we calculate the magnetic moment of this one, so the formula of the magnetic moment is equals to √ of n times n plus 2. There should be the bracket here, right? And since number of n is 4, because 4 unpaired electrons are there, if you solve this out, you will get the magnetic moment of this 4.89. Okay.